Let's talk about this invisible force that makes you fly and understand all the little quirks of it. In this video, I'm gonna tell you a bunch of things that are gonna help you better understand the world of sailing. Ready, go!
Everybody just get on down.
To talk about the wind direction with respect to the beach, we say it's offshore wind when it's blowing from the land towards the sea, onshore when it's like this, and sideshore when it's like this. The diagonal directions are just called side on or side off. The wind direction with respect to the shore is important to us because it tells us a few things. Offshore wind is the most dangerous because it takes you out into the sea and you have to remember that there is always some drift. So if you just ride back and forth on the crosswind line, you'll gradually end up further and further away from the shore. So you can only ride with offshore wind if you know how to go upwind efficiently and if you have some sort of emergency plan like having rescue boats around you. Side-off wind is a bit less dangerous because it's possible to come back more easily, but it still requires you to have some sort of emergency plan. The good thing about offshore winds is that land usually makes the water flat, but on the other hand, it also turns the wind pretty gusty. Onshore winds instead tend to be more constant, but they can bring a lot of chop and waves, and the difficult thing when the wind is exactly onshore is that as you enter, the current will immediately bring you back to the shore. And so this requires you to be quick at taking off and riding upwind to take some distance from the shore. Sideshore winds instead give you less chop than onshore, but normally are still more choppy than flat offshore winds. The good thing about it is that you will be able to ride perpendicular to the beach, but the drift, since it's exactly parallel to the beach, will make you move a lot to the side if you're not able to go upwind. Imagine is a perfectly still day, kind of like here, indoor, and you start moving in one direction at 20 knots of speed. You are going to feel in your face 20 knots of air. And by the way, 1 knot is equal to 1 nautical mile, which means 1.8 kilometers per hour or 1.15 miles per hour. Anyways, for now, we don't really even care about how much speed that is. What we care about is to understand that as you move, you are moving relative to the air. And so it feels like suddenly there is wind coming right from the direction of your motion. This is called headwind. And as you start sailing, the real wind will sum with the headwind, and what you will feel will be this sum, called apparent wind. If you want to calculate the apparent wind, you have to do a vectorial sum of real wind and headwind. But we don't need that much precision, we only need to understand that their direction will also sum. So, if you're riding crosswind to the real wind at the same speed of the real wind, it will feel to you as if the wind is coming exactly diagonal. This is the reason why when you handle the wing on the beach, your leading edge will always be pointing towards the wind like this, and if you give your back straight to the wind, you will be a little bit twisted like this. While when riding in the water, you can give your back straight to the wind, and because of your motion, the wing can stay more in front of you. And this is simply because the apparent wind is actually coming not exactly from your back, but more from the side. When the wind is very light, your speed will be a huge factor determining the apparent wind, and you can check the consequences of this in the video Light Wind Wing Control. Another consequence of this dynamic between your motion and the wind is that if you go completely downwind, you're actually going to start moving together with the air, and so your motion relative to the air will be less than if you stood still. If you move at the same speed, you'll feel exactly zero wind, and if you move even faster than the wind, then you will feel just a little bit of headwind. This is in fact something that happens frequently as you are surfing waves. Even if you are not going completely downwind, still a little bit of your speed will cancel out some of the real wind. So, past 135 degrees with the wind, sailing generally becomes somewhat inefficient. Now, since we cannot see the air, it might be useful to reflect for a moment on how it actually works. Normally, we just draw an arrow to say the wind is coming from there, but to think of an arrow can be actually a little bit misleading. The wind is not made of straight lines, the wind is actually a moving mass of transparent gas. Think about the sea. It's a big mass of water always in motion, and the air is the same, just more transparent. The motion of a flag is the most telling because it tells you the direction of the wind, but it also shows you the intrinsic wavy motion of it. The particles of air are bouncing against each other and they're never moving just on a straight line, rather on this erratic path on a shared general direction. And when the wind finds an obstacle, here's when things become more evident. The wind tends to stick to a surface as much as possible, and as soon as that surface disappears, it will start creating little whirlpools. These whirlpools, or just turbulences, will propagate for a distance that can be 7 times the height of the obstacle. This behavior of the wind is also involved in the functioning of the wing. When the wind beats against the leading edge, the airflow splits above and below it, and sticks to the profile of the canvas as long as the curve it has to do is not too sharp. So when the angle of attack is too big, the airflow ends up spiraling into turbulence, and that's the phenomenon that we called backstalling. When the wind is offshore and it's bumping against the land and possibly some buildings or trees or whatever, the wind that you receive will be very messy, and you will notice how this wind feels much more difficult to control and make use of. When wind is your engine, you need to be able to see this invisible force. And when you get at the beach and are trying to judge what kind of wind you have, there are quite a few signs that indicate to you what kind of wind you have. The sea is probably the most important. If you look at the surface, you'll be able to notice that it seems to move in one direction, and that will roughly be the wind's direction. Then, based on how agitated the surface of the water is, you can also tell in which point you have more or less wind. Here I'm talking about a very superficial agitation, not about waves and chop. Flags, trees, and simply the sensation in your skin are also great detectors of wind. But using them all is the best way to get a complete picture of what the wind is like. Sometimes, in the space of just 100 meters, there can be two completely different winds, and having some wind indicator over there will help you in making your decisions. I can give you an example of one time where I was riding with this wind over here and wind from here was coming. The moment I saw the flags on the beach turning around, I came back as quickly as possible and I managed to get close to the beach with this wind and limit the amount of swimming I had to do. Wind is a really cool thing to get geeky about. Airflow, is the reason why wings work, even birds' wings, or even any sail, really. So I'm gonna give you a little example with this paper sheet. If I blow underneath, it goes up. And if I blow above, it also goes up. Why? I actually mentioned the reason in this video, so think about it, or maybe go back and watch it and then let me know in the comments. This video is part of a playlist called Beginner Technical Knowledge, which is a support playlist to the beginner course, which is entirely available on this channel. So go check out all the videos, enjoy, and keep flying.